This lab will be looking at the concept of a mole because moles are extremely important in chemistry for making measurements and knowing amounts of reactants that we need in order to produce a certain amount of products. So this allows us to compare amounts of substances without actually counting individual molecules. And there's lots of different ways that we find the number of moles. So one such way is using the molar mass off of the periodic table for each of the elements, and the units for this is grams per mole. The other way that we can compare moles is by looking at the molar ratio. So the coefficients, which is also called stoichiometry, the coefficients in front of a balanced chemical reaction in order to compare moles of one reactant to moles of another, or to products as well. We're going to also be looking at the idea of percent yield. And percent yield comes from the actual yield, which is found experimentally. So this is the amount that is actually produced in our experiment, and comparing that to the theoretical yield, which is the amount, the maximum amount that could be produced from the reactants. So we find theoretical yield from the reactants. So it's the maximum amount that could be produced. To find percent yield, we take actual yield divided by the theoretical yield times 100%. We're going to be looking at two different chemical reactions in this experiment. And so this is similar to the volcano reaction if you've ever taken baking soda and vinegar and mixed them together. It produces a salt, carbon dioxide, and water. Well, we are going to take baking soda, which is also known as sodium hydrogen carbonate or sodium bicarbonate, and we are going to add hydrochloric acid. So instead of vinegar, we're going to use a strong acid that is hydrochloric. The products that we end up with are sodium chloride, carbon dioxide, and water. So carbon dioxide is a gas, and so this is the bubbles that you're going to see that are given off as the reaction progresses. This is also going to be how we identify when we've reached the end point, when our reactants have completely reacted. We're going to also produce water, which is a liquid, and so in this experiment we're going to have to heat up our products in order to remove the liquid water so we can identify how much sodium chloride is produced in our chemical reaction. Another reaction that we're going to do is we're going to use sodium carbonate and hydrochloric acid to produce the same products: sodium chloride, carbon dioxide, and water. And you'll notice here that our coefficients are different for the amount of acid and the amount of salt that is produced. And so when you find your theoretical yield, you're going to have to make sure that you remember your stoichiometry, your coefficients, in order to do your calculation. The procedure that we're going to do is we're going to make sure our test tubes are clean. We want to make sure we weigh them empty with a boiling chip. We're going to add about 0.5 grams of our sodium bicarbonate or sodium hydrogen carbonate. And then we weigh the test tube again with that starting material. This will allow us to determine the amount of sodium carbonate and eventually our theoretical yield. We'll slowly add hydrochloric acid until all of the carbon dioxide has been produced, and this signals the end point of our chemical reaction. In order to drive off the water, we're going to heat up the test tube in order to dry the sodium chloride using a Bunsen burner in the hood. We'll weigh the test tube and the dry sodium chloride to determine our actual yield. We're going to reheat and weigh until the masses are within 0.005 grams. This allows us to know that we have completely dried the test tube, and after it is completely dried, that is what we use in order to determine the actual yield. We're then going to repeat this experiment and the same procedure using sodium carbonate. We do want to make sure for safety that we're slowly adding the hydrochloric acid so that the contents of the test tube do not bubble out. And we want to make sure that we don't point the test tube at anybody while we're heating in case there is any spattering of the substance inside the test tube out, because some of the moisture will be trapped in under the crystals of sodium chloride. We are using a fairly concentrated hydrochloric acid, so 6 molar hydrochloric acid, and so we want to make sure that we're careful to not come in contact with our skin. If we do, we want to make sure we rinse it off and let your instructor know that you have come in contact with the hydrochloric acid, but you do want to rinse it with lots of water if you do get it on you. The test tube holder that we're going to use can get hot, so you want to hold the test tube holder at the very end of it and make sure that you don't accidentally touch yourself with it, because we are going to be heating it in the flame, so do be careful. If it starts getting warm, take it out of the flame, set it down in your beaker so that you do not burn yourself. And this can get a little messy, so if you do make a mess, make sure that you clean it up. All of the sodium chloride that is produced can go down the drain. Any excess hydrochloric acid needs to go into a waste container. You are going to be making measurements for many of the blanks in your Excel sheet. And so you'll be recording many of the masses. Some of them are going to be mass by difference, such as the mass of the starting material. So you'll want to calculate this by subtracting off the mass of your test tube, the beaker, and the boiling chip in order to find just the sodium hydrogen carbonate or the sodium carbonate that you start. The moles of the starting material, make sure that you're using dimensional analysis and you end up with the proper units. But in order to find the moles, you're going to need the molar mass of your starting materials, and they are different from each other, so make sure you're using proper molar mass for each of your calculations. The theoretical yield, you are going to need your molar ratio, so you're looking at your stoichiometry or your coefficients in your balanced chemical reaction to go from moles of sodium hydrogen carbonate to moles of sodium chloride, or in the case of sodium carbonate to sodium chloride, in order to calculate your theoretical yield. And then you can calculate the theoretical yield in grams using the molar mass of your product, which in this case is sodium chloride. Okay. You're also going to want to record whether or not it's exothermic or endothermic. So if it feels cold, it's endothermic. If it feels hot, it's exothermic. After we've dried the test tube, we're going to have to take multiple measurements to make sure they're dry. And so you're going to record those measurements here. You want to use the smallest mass because that is theoretically the driest product that you have in order to calculate the mass of your sodium chloride produced. So you're going to use your smallest mass and subtract off the test tube, the beaker, and the boiling chip in order to find the mass of your sodium chloride produced. From that, you can calculate your percent yield by taking the actual divided by the theoretical times 100%.